Question 9. Question 9 is circle theorem. It says H, J, K, L, M are points on the circumference of a circle. MK is a diameter. And then they tell us that MJ is equal to JL and JMK is 38. So now we need to go ahead now and explain why angle HJM, so the angle HJM, the angle at J, HJM, explain why that is 38. So this right there, HJM, is 38. Now angles subtended by the same chord are what? Equal. So no problem. Angle subtended by same chord. Those are equal, no problem. Now, the 90 degrees now is MJK. MJK. Angle is 90. Now, angle subtended by the diameter MK is 90. No problem. Because angle subtended by the diameter is 90 degrees. No problem so far. Easy. Now, determine the following angle MLJ. MLJ. So MLJ. So this angle I want, MLJ. Let's see how we're gonna get this angle. Now, what we do know is that angle MLJ, we know this angle right here should be equal to this angle right here. Now, what do we know? We know this angle is 90, angle is 38. So the angle down here then is going to be 180 minus 90 plus 38. That's 52. This is 52. Angle subtended by the same chord, so it's also 52. That angle there is 52. So we can tell them 52 degrees, and the reason is angle subtended by the same chord are equal. So we can tell them that is angle MLJ is equal to angle LJL. Well, it's equal to angle JKM. So that's the reason. Now we need to find angle LJK. LJK. We need to find angle LJK. So we need to find the small piece. Okay, we need to find the small piece in there. How are we going to find that small piece now? Let us see. So we need this small piece. Okay, no problem. All right. So we know that HJ is parallel to this. All right. So co-interior angles are coming into play. All right. Once they're parallel, two parallel lines, transversal line. Okay. All right. That won't assist us in this moment. All right. So no worries. We'll find out that one. So let me just look at JHM first. Is that one look easy? JHM. I know this is a cyclic quadrilateral. This is a cyclic quadrilateral. So if this is 52, this is 180 minus 52. I'm just putting that there, see if I can work that out straight away. So 180 minus 52, that's 128. So this is 128 degrees. And the reason is because it's a cyclic quadrilateral. 128 degrees. The reason? Cyclic quadrilateral. Alright, angle LJK. We need this last one. Let's go, let's go. This is so fun. Right? So we're in here. I realize it's also a cyclic quad, but how does that benefit us? Knowing that this is a cyclic quad, can the cyclic quad benefit us? We know opposite angles in the cyclic quad sum to 180. So we know all of this, 38, and this 90. Let's see if it will benefit us. Look at what we're saying. We're saying all of this right here, right? We're saying all of that. Okay, yes, it can benefit us. Can benefit us. All of that is 128. And if this is 38, for it to add back to 180, then this piece would be, let me see, I think it's 14 degrees. If this piece is 14 degrees, how is that useful? Let us see. Is this piece down here then 14? Let's see if the mathematics would make sense. So if this piece is 14, then this and this add to give you 52. Angle subtended by the same chord. Yes, that is 14 degrees. So around here, this would now be 14 degrees. That's it. Alright, so remember it's not drawn to scale. So angles subtended by the same chord are equal. So this piece must be 14. So this piece is 14. We're good to go. That's it. Part B, it says from a port L, they give us this information. They're going to ask you to insert the information given. So complete the diagram above by inserting. So L is 250 kilometers on a bearing of 65 degrees. So port L, so from port L, this is our from position. Ship R is on a bearing of 65 degrees. So this is your 65. Then they tell us that ship T is 180 from L. So from L on a bearing of 148. So all of this is 148. In this case now, 148 minus the 65 inside here is 83. So we put in angle RLT, I mean 83 degrees. Now calculate the length of RT. So to find RT, we're going to use cosine rule. You have this side and this side, you need to find RT. So you're going to use cosine rule now. So using cosine rule, we can tell them RT squared is equal to LR squared plus LT squared minus 2 times LR times LT times the cosine of theta. So RT squared is equal to 250 squared plus 180 squared minus 2 times 250 times 180 times the cos of 83 degrees. Punch that in your calculator. For your calculator, 250 square plus 180 square minus 2 times 250 times 180 times the cosine of 83. Punch that in the calculator. And then this is RT squared. So when you square root it, you're going to get RT. RT squared is 83,932. RT is in the square root of 83,932. So square root it. And I'm going to give them to the nearest kilometer. And so RT is equal to 290 kilometer. RT. Now it says determine the bearing T from R. So we need the bearing T from R. The bearing of T from R, we need the from position is now at R. So notice if we break it up in dotted line, we know it is 180 degrees plus this piece. Now 180 plus that piece would give us our answer, but how can we find this piece right here? Right, we already know this piece, right? So we can always find this piece. Well, let's continue. Look what I'm saying. If we were to break it this way, right? Follow what we're doing. This is 90, then this is already what? This piece, we know if this is 65, then we know that piece is, I want to make sure it is good. If this is 65, then I am positive that this piece would be 25 degrees. Good. So in that case now, really and truly, to find this piece in here, right, then we can subtract it, right? We can find this piece using what? Sine rule. So let's call this y. If we call that y, what do we know? Right? What do we know? We can find y. Come on, let's find y. Right? So we can find y, and then we're good to go. Because once we find y and we add 25 and we subtract, then that way we can get this piece right here and add it to 180. Right. So let's go ahead and do that. We need to find y, add it to 25, subtract from 90, then the result will add to 180. So let's go ahead and do that. So to find y, what do we know? We know that sine y over 180 must be equal to, which angle we know? The 83. It's equal to sine 83 over, this side we said RT was, I think it was 290 or 289.7. So if we cross multiply, we'd end up get sine y times 289.7 is equal to 180 sine 83. Then we divide both sides by 289.7. This cancel this. So now we just sine inverse it. So y is equal to sine inverse of 180 sine 83 over 289.7. Put all this in our calculator one time. So we get sine inverse, fraction button, 180 sine 83, close the bracket, over 289.7. We work that out and we get 38 degrees. So we get y is roughly 38.1 degrees. Now once I get y is 38.1, remember then we add 38.1 to 25 degrees. And remember we subtract it from 90. So when we add those and subtract from 90, we get 26.9 degrees. Then the bearing just equal to 180 plus 26.9, and that works out to be, add it to 180, that's it, 206.9 degrees. That is it. Easy. Okay, that's the bearing T from R. Now, this right here, it says the transformation matrix A represents a 90-degree anticlockwise. The transformation B represents a reflection in the straight line y equal minus x. Determine the coordinates of P prime, the image of P after it undergoes a 90-degree anticlockwise rotation. So P prime, remember, now all we're going to do is multiply this matrix 0 minus 1, 1, 0 times 7, 11, row by column, 0 times, so remember row by column, 0 times 7, and we have minus 1 times 11, and down here going to be 1 times 7 plus 0 times 11. That is working out to be, this is P prime, this is 0, minus 11, so it's minus 11, comma, positive 7. That's P prime. Now it says T is a combined transformation of A followed by B. So T is A followed by B in B times A. Determine the elements of the matrix representing T. So B times A, so multiply 0, minus 1, minus 1, 0 times A, and A is 0, minus 1, 1, 0. Multiply them now, it's going to be row by column 0 times 0, then minus 1 times 1 is negative 1. Row by column 0 times minus 1 times 0 is 0. Minus 1 times 0 is 0. 0 times 1 is 0. And then row by column minus 1 times minus 1 is 1. So this is it. So just to check it again, row by column 0, minus 1, and row by column 0, 0, 0, 0. Yeah, that's it. So it's minus 1, 0, and then 0, 1. Now describe fully the transformation T. Now I don't know what this is off my head, but what I can do is make up something. Let's say I have a point Q somewhere 5, 3. Q is 5, 3, undergo minus 1, 0, 0, 1. What happened? If I just multiply to notice this will become minus 5, positive 3. Let me see. Yeah, minus 5, positive 3. So if I have a graph and Q is the point, this is 5, 3, then minus 5, 3 is, minus 5 is over here, positive 3 here. This is Q and this is Q prime. So I notice then that this matrix look like it is a what? It look like it is reflection. So it becomes now a reflection. So this is now a reflection. Describe the geometric, it's a reflection in the y-axis. Describe geometrically the transformation represented by T. T represents the reflection in the y-axis. It's just reflection in the y-axis. That's it. Now it says the 2 by 2 matrix in terms of the scalar constant C is such. And it says determine the value of K for which C is singular. If C is singular, then the determinant of C is equal to 0. So now the determinant is 3 times 4 minus 6 times K, and that's 0. So that's 12 minus 6K equals 0. So 6K is equal to 12 and so K is equal to, that's it. K is equal to. Next part now. Okay, give us some information and they ask us to find vector bx. I love these questions. Vector bx. Vector bx is just vector ox minus vector ob. Now I know what is OX. OX is U minus vector OB. Now, they told us what OY are extended so that Y is the midpoint. So if Y is the midpoint, right, and OY is V, and this is also V, and so OB then must be 2B. So it's U minus 2V, right? That's it. So to go from O to B is 2V. Now it says, given that YA and BX intersects at M and BM is 2MX, determine vector BM. So now it tells us that YA and BX intersects at M, and vector BM is a vector BM is 2 times vector MX. Now that is now 2 times vector OX minus OM. That will give us vector BM. Now, what is this OM again? It says YA and BX intersects at M. So YA, or to draw a line, YA, this is YA. I don't want to use the black. Let me change the color. I like to see it visually. This is YA, and this is vector BX, and they say they intersect at M. They intersect somewhere here. This is OM, right? So if that is OM, right? That is OM, right? So we need to find OM. That's what we need to do. So we need to find OM. And to find OM, realize that we can go to O to A and then A to M. Or we can go O to Y, then Y to M. It's up to you. It's up to you. It depends on how you'd want to do it, right? Because you can't go straight from O to M, right? Because that's all we do now, right? And they say BM is 2MX. Okay, so we actually need to find OM first. So remember, I don't like that it's 1 mark because we don't even know OM, right? We don't know OM, right? We don't know OM, so we have to find OM first. Once we find OM, then we can find vector BM, right? So this would be OM minus OB. That's equal to 2. Come on and stop that. And this is now 2 in bracket OX, and we know what is OX. OX is U minus OM, and OB is 2V. So OM minus OB, and OB is, we said OB was what again? 2V equal to 2U minus 2OM. We bring the OMs to one side, so 3OM is equal to 2U plus 2V. They will divide it by 3. So that's vector OM. Vector OM is 2U plus 2V all over 3. Now we can go ahead now and tell them what BM is. So BM, which is OM minus OB, is just going to be OM, which is 2U over 3 plus 2V over 3 minus OB, which is 2B. So vector BM is just 2U over 3. Then this is now 2 over 3 minus 2. You can always just take out your calculator. Can't bother to stress yourself. 2 over 3 minus 2. That's minus 4V over 3. That's what we got. Nice. So minus 4V over 3. Oh, good. Next part, using a vector method, show that the ratio of ym to ya is 1 to 3. So first thing, let's find vector ym. That's om minus oy. Good thing we already find vector om. Vector om is 2u. This is om again. 2u plus 2v over 3 minus oy. And oy is, oy we said was v. So we do our subtraction and we get, this is 2u over 3. 2 over 3 minus 1 is minus 1v over 3. Then now, that's vector ym. Now we need vector ya. Now vector ya, that's equal to oa minus oy. And is, oa is, where is oa? Oh, here is OA, sorry. And X is the midpoint. So OA is, this is U as well. So OA is 2U minus OY. And OY is what? OY is V. So that is it. So now the ratio of YM to the ratio of YM to the ratio of YA now, that's equal to 2U over 3 minus V to 2u minus v. Now, yeah, it is true now, because to show by a vector method. So now, look how we're going to show that this right here is just 1/3. This is indeed 1 to 3. To show that this is 1 to 3, see it here? 2u over 3 minus v over 3. If you multiply it by 3, that is giving you, if you multiply it by 3, that is giving you, as you can see, multiply it by 3, 2u over 3 times 3, that is 2u, and v over 3 times 3, that is v. In other words, it is telling you that this part right here, which is ym, is telling us ym times 3 is equal to ya. Notice we're saying that ym times 3 is equal to vector ya. In other words, if we divide by look what we're saying. Ym times 3 is ya. So 3 ym equal ya. So if we divide both sides by ya, we're saying then that, look what we're saying, if we divide it by ya, come on, pen, stop it. And this would cancel that, so we're saying 3 ym over ya is equal to 1. Then we just divide both sides by 3. And so we realize that ym divided by ya is 1 over 3. Since we get it's 1 over 3, that would prove that the ratio is indeed 1 to 3. So that's it. We've done it. Nice. We finished, and that concludes the maths paper. I mean, it wasn't that bad. It was a nice paper. It was fun. Right? Nice paper. That's it.